In this session, we will take a look at questions based on boats and streams. And in the next part of the same session, we will also take a look at questions based on escalators, which are very similar in nature. But before that, let us look at the basics of boats and streams. The speed of a body in stagnant water will always be designated as x in this session. And similarly, the speed of river or the stream or the escalator will always be designated as y. Downstream implies with the direction of flow. So when the body travels in the direction of flow, we say the body is traveling downstream, and when the body travels against the direction of flow, we say the body is traveling up the stream. The upstream speed is given by the difference of the two speeds x and y. So upstream speed SU is equal to x minus y, and similarly the downstream speed designated as or represented as SD is equal to x plus y. Let us look at a few simple questions based on boats and streams. A man can row at a speed of 8 km per hour in still water. If he travels in a river which is flowing at an average speed of 3 km per hour, find the time taken by the boy in traveling 33 kilometers downstream and 15 kilometers up. So from the given data in the question, we have the downstream speed, which is equal to the sum of the speed of man in still water and the speed of the river, that is equal to x plus y, is equal to 8 plus 3, that is equal to 11 kilometers per hour. Similarly, the upstream speed from the data given in the question is equal to x minus y, which is equal to 8 minus 3, that is equal to 5 kilometers per hour. Now again, the boy travels 33 kilometers down the stream, which is represented as segment 1. Similarly, this boy travels 15 kilometers upstream, which will be represented as segment 2. So again, we go back to our concept that we learned in the previous session. The total time will be equal to the time traveled in two different segments. In this case, the two different segments are downstream segment and the upstream segment. So the time required in the downstream segment is represented as TD plus TU, that is the time required in the upstream segment. So this must be equal to d by SD, which is the distance divided by the speed traveled in the downstream, speed of downstream, d divided by SD, which is equal to the downstream speed of the man, plus d upon SU, which is the time taken by the man in traveling upstream. So if we put in the values in the above equation, we have total time is equal to 33 by 11. 33 is the downstream distance, 11 is the downstream speed, plus 15 upon 5, where 15 is the upstream distance and 5 is the upstream speed, which gives rise to 6 hours. Let us take a look at another similar question. A man travels in a river some distance downstream and the same distance upstream. He finds that he takes 5 times as much time to travel upstream as he takes to travel downstream. Find the ratio of the speed of man in still water and the speed of the boat. So what is the most basic equation here? Let us look at the schematic diagram first. The 2 points between which the man travels are B and S as shown in the figure. Downstream is S to B and upstream is B to S. So when the man travels upstream, he takes the time TU which means the time required to travel upstream. Similarly, when the man travels downstream, the time required is Td. The question very clearly states that the time taken to travel upstream is 5 times the time taken to travel the same distance downstream. So this is our basic equation. Tu is equal to 5 times Td. Now, Tu can be replaced by distance divided by the upstream speed, that is Su, and Td can be replaced by d upon St. D is again the distance, which is the same as the upstream distance, and Sd is the downstream speed of the man, and d upon Su must be equal to 5 times d upon Sd. So we place appropriate values. D upon x minus y is equal to 5 times d upon x plus y, where x is the speed of the man in still water and y is the speed of the river. When you simplify the above equation, you get x plus y upon x minus y is equal to 5, and on further simplification you get the value x upon y is equal to 3 by 2. Let us look at another question. A man travels 33 kilometers down a river and 20 kilometers upstream the same river in 7 hours. If he had traveled 30 kilometers upstream and 22 kilometers downstream, he would have taken 8 hours. Find the speed of the man and the speed of the flow of river. So there are two cases which we can clearly see in this question. In the first case, a total time of 7 hours is required, and in the next case, in the other case, the man requires a total time of 8 hours. Again, the total time of the first case, that is 7 hours, is equal to the time traveled in downstream direction plus the time traveled in the upstream direction. We replace time traveled in the downstream direction by the appropriate distance and speed. So time downstream is 33 kilometers, which is the downstream distance in the first case, divided by x plus y, which is the downstream speed, plus the time upstream can be represented as 20 upon x minus y, where 20 is the upstream distance and x upon y is the upstream speed. This is represented as equation 1. Similarly, 8 is also equal to the time traveled in the downstream direction plus the time traveled in the upstream direction. This is for the second case. In the second case, the downstream distance is 22 kilometers. So Td for the second case becomes 22 upon x plus y plus Tu, the upstream time for the second case, becomes 30 upon x minus y, because 30 is the distance traveled in the upstream direction in the second case. Let us represent this as equation number 2. When you simplify both these equations, you will get x plus y is equal to 11 and x minus y is equal to 5. And on solving both these equations, we get x is equal to 8 km per hour, which is the speed of the man in still water, and equal to 3, which is the speed of the river. So with this, we come to an end of this session. If you have any feedback or if you have any query, please feel free to contact us at student services. Please feel free to contact us on studentservices@pfindia.com. Thank you.